video from yesterday, if you are still confused, befuddled, hoodwacked with it, the video is up on It's Learning, where all of our other videos go. Okay? So, I wanted to start today with the speed chart. Okay? Once again, the speed chart is good in terms of it tells you the things that you need, the units that they need to come in, and it shows you where you can go, kind of a deal. Okay? So, for instance, if I have revolutions, okay, I want to say 7 out of 8 problems are going to start with motor is running at 2,000 RPM, let's say. Okay? That's revolutions per minute. Okay? So that's going to be rotational speed, revolutions per minute. Okay? We can easily convert that into radians per time unit by 1, changing our unit of time. If we wanted to go per hour, or however we wanted to do it, per week, whatever you wanted to do, we can do some unit conversions on that. Okay? But we can also multiply by 1 revolution is 2 pi radians. Okay? 1 revolution is 2 pi radians. Okay? And that gets us then into angular speed, because now we've converted our revolutions into radians, and radians is a unit of an angle measure. Okay? From there then, based upon the radius of the whatever is spinning, we can go into linear speed. How far a point on the end of that circle is going if we were to be like driving down a road. Okay? If you could somehow always drip, paint onto your wheel, you would leave a paint line along the road. That's a distance. Okay? And so we can find that linear speed, and then we can convert that linear speed into a distance. Okay? All right? So very important stuff going on there. Okay? So this is where that was the last one that we did yesterday. So let's start here. A bike with a 28-inch diameter wheels is racing at a speed of 36 feet per second. How many revolutions per minute are the wheels making? Okay? So, how I would start this one is you've got you've got 2 different units going on here. You've got 28-inch diameter, which is the size of the wheel, and you've got the speed of the wheel at 36 feet per second. So I would start with 36 feet per second. Okay? We want to get to revolutions per minute. So do you want to trade or change the feet first, or do you want to change the seconds first? Because we're going to have to change them both, right? Change the seconds first. Okay. So how many seconds are in a minute? Okay. So now my unit is in feet per minute. So I've got the per minute part. Done. Okay. Now I just got to create revolutions. Okay. So I can convert. So this is in feet per second. If I go back to my speed chart. Come on now. There it is. Okay. So I'm in feet per second. I need to get into revolutions per minute. So I need to go up the speed chart. So first I need to get it into radians. Okay, so let's get this bad boy into radians now. Okay, so how many feet is a radian? Seems like a logical. 14 inches is a radian, right? Okay, so before I can utilize my 14, oops, I think now, nope, it'll be on top. Before I can utilize that 14 inches is 1 radian, what do I need to do? I got to convert my feet into inches. So 1 foot is 12 inches. So now feet are gone, and now I'm in inches per minute, which now then I can use that. 14 inches is 1 radius, which 1 radius is a radian. So now I'm in radians per minute. Is that good yet? I'm in radians per minute, but what do I want to be in? Revolutions per minute, so I've got to go one more step, and I've got to say that there are 2 pi radians in 1 revolution. Okay. So on top, I get 12 times 60 times 36 Oh, come on now. So that gets me 25920. On the bottom, I've got 28 pi. So that gives me approximately 294.66 revolutions per minute. Questions on that one? Okay? So, Mrs. Hill wrote this problem. Can you tell? Because she was Grant. Okay. So, during the spin cycle, Mrs. Hill's washing machine rotates at 1400 RPMs. If the drum has a 27 centimeter radius, at what speed is Grant's lost sock spinning at? Okay? So find me the speed of Grant's lost sock. Alright, so spinning at 1400 revolutions per minute. Okay? We want miles per hour. You want to do the revolutions first, or do you want to do the time first? Time first? Okay. So there are 60 minutes in 1 hour. So now I'm in revolutions per hour. Okay. So I've got the hour part. Now I've got to get revolutions into miles. So there are 1 revolution is 2 pi radians. 1 radian is 27 centimeters, right? So now I have gone from revolutions per hour to radians per hour to centimeters per hour. There's 2.54 centimeters in an inch. Hold on, I'm going to move this all down here. Give us a little more spice. So now we've got to go the centimeter part. So there's, what did you say, 2.54 centimeters in 1 inch. So now I'm in inches per hour. 12 inches is 1 foot. 5,280 foot is 1 mile. Yes'm? Okay, so let's start doing some math. 1,400 times 60 times 2 pi times 27 divided by 5,280 divided by 12 divided by 2.54 gets me that the sock is spinning at 88 we'll go 547 miles per hour. Yes? Okay. Now, follow-up question to that one is, what is the distance that that sock traveled in a 15-minute spin cycle? So it's staying on the edge, okay, because that's where it's spinning. Centrifugal force will push it out to the edge. So how far did that sock travel in 15 minutes? Well, that sock is traveling at, I'm going to leave it on my calculator, but for purposes of writing it down, I'm going to write it down as 88.547 miles per hour. Right? Okay, or we can just multiply it by 0.25, but if we wanted to show that work, then, okay, so then now I got 15 minutes. Well, 15 minutes is, as Luke just said, 0.25 of 1 hour. Okay, that's my time. Okay, so you could divide by 4 or multiply by 0.25. Okay? Either way, what I really wanted to show was you don't multiply by 15. Okay? Because they're not the same unit. They don't cancel each other out. So divide that by 4. So that sock traveled 22.137 miles. I want, yep, I'll go back one. And then I want to go here. And I want to talk a minute about, the book calls it sectors. I think it was called a sector on your worksheet. Some people might call it a wedge. Okay? Some people might call it a slice of pizza. Okay? If you've ever been to Polito's downtown, you get the big slices of pizza. Let's just use the Polito's big slice as our model here. What's the radius on a big slice? Is it 14? Across, right? So 14. So the radius of a Polito's big slice of pizza is 14, right? Okay? Which means then that this edge is also going to be 14. Right? Okay? So there are two different types of questions that can come out of the pizza wedge or the slice of pizza problem. Area and perimeter. Okay? So to find the area, or to find the perimeter first, so you need to know then, you would have to know what theta is. And you need theta in radians. Okay? So let's say theta is, what do they cut them up into 8 pieces? They go 8 or 10 at Polito's. I forget. It's been a while since I've been there. Anybody? Let's say 8. Okay? Let's say 8. So they cut it up into 8 pieces. So you got a Polito's pizza cut up into 8 pieces. What's theta then? 45 what? It's 45 degrees. Oh, I don't know what's going on. Oh, what's going on there? Oh, I see what was going on there. We had inches here and it came down there. And so let's say theta here is 45 degrees because we got 8 pieces of pizza, right? So what do I need to do first? Convert 45 degrees into radians. How many radians? Pi over 4 radians. Now, my arc length S there is equal to theta times my radius. So that's going to be pi over 4 times 14, which is 7 pi over 2. Okay. So my perimeter is going to be 14 plus 14 plus 7 pi over 2. Because there's 3 sides to my slice of pizza. Okay. So that would be 28 plus 7 pi divided by 2. So that would have a perimeter here of 38.996 inches of tasty goodness. Okay. The area of my sector, first I've got to find the area of my whole circle. Plus 14, is that 196? All right? But I only want a portion of it. So the area of my sector is going to be pi over 4 divided by 2 pi, because that's the part of my circle that I have. Or I could have done 45 degrees divided by 360 degrees. That's the part of my circle, that I have. Okay? Times, then, the area of the whole circle. Okay? So pi over 4 divided by 2 pi should be what? If it's a 45 degree chunk, what fraction should that be? Should be 1/8. Okay, 1/4 would be a 90 degree chunk. Okay, half of that, so that should be 1/8 times 196 should get me, and then times, so that's 24.5, and then multiplying that by pi. So the area here is 76.969 square inches of chicken bacon ranch delight. If you're Lucas Linsmeyer, then it's macaroni and cheese delight. That's the mac and cheese pizza. Okay? So a couple of sector ones there. Okay? Now, what I'd like to get into these last 15 minutes is when you've got a belt driving something. Okay? So you got a motor hooked up to a pulley, and that's spinning, and there's a belt or a chain or a rope or something that's driving something else. Okay? Very common problem on this one, a bike. If you think about when you pedal a bike, you've got the pedals are attached to the drive socket, okay? And that drive socket is making the back tire move. And they're on you can do multiple different, if you've got a 21 speed bike, you could change, and you can make it go easier, you make it go harder, which makes you go faster, and stuff like that, okay? So that's a common problem. So the problem reads, the belt on an electric motor connects metal wheels with radii of 2 inches and 5 inches. We went lowercase r and capital R just to signify which ones they are. The rotational speed of the larger wheel is 120 RPMs. In the book, call it angular speed with units of RPM. Okay? Find the angular speed of the larger wheel in radians per second. Okay? Well, the larger wheel is spinning at 120 revolutions per minute. We want that in radians per second. Make that conversion for me, please. Oops. Crossed out the wrong one. So 120, 60 gets divided into that twice. So I get here 4 pi radians per second. Do we concur with 4 pi radians per second? Okay. Now I'm not going to round that one to be 12.56. Okay? Because I'm probably going to have to use that later on in the problem. So I'm going to leave it whatever fraction I get there. Okay? What is the linear speed of the belt? Okay, well, that belt is going around it's going around the first one at 4 pi radians per second, correct? Or on the bigger one. Okay? So the linear speed then, now I would take that 4 pi radians per second, and I would multiply that by 1 radian is how many inches? Radian or radius of the larger wheel, 5 inches. So the speed of the belt is 20 pi inches per second. Now it says, what is the angular speed of the smaller wheel? Logic tells me that if the bigger wheel is spinning at 4 pi radians per second, okay, and they're connected by a belt, is the smaller wheel going to be spinning faster or slower than the bigger one? Faster? Got to be going faster, because remember that belt is traveling at a constant 20 pi inches per second. So that's where you go. You go off of the linear speed when you're transferring to a different sized pulley. Okay? So that belt is traveling at 20 pi inches per second. Now I want to convert that back into angular speed. Well, hello there. So that belt is traveling at a constant speed. Okay? All right? And so now we've got to convert that back into radians per second. So then I'm going to go with 1, oops, come on now, there it goes, 1 radian here now is the radius of the smaller sprocket, pulley, whatever you want to call it, and the radius of the smaller one was 2 inches. Okay. So the angular speed then in radians per second of the smaller pulley is 2 goes into 20 10 times, so that would leave me with 10 pi radians per second. Okay. So it is going faster, which you would think. Okay? If you've ever pedaled a bike and you shift into one of those really small sprockets on the back, okay, you speed up, right? Because if you pedal at the same rate, now you're making that back tire spin a lot faster. This way. Forward. Okay? All right? So you're making that back tire spin a lot faster. Okay? All right? We'll pick up on this more tomorrow too, but that's kind of where I wanted to stop today. You should be able to do now, on the pink homework sheet, you should be able to do now through 4.1b. So those first 2 homeworks you should be able to do, along with the 2 worksheets, the 4.1a and the 4.1b worksheets that you got Monday and yesterday. Okay?